To use and name a ionic compound, okay, we want, well, to name any compound, really, we can use this flow chart for naming, okay? Now, what we're going to do is we're going to do some sample problems down here below, right in this little area, okay? We have, keyboard, CaCl2, CCl4, Fe2O3, N2O3, MgSO4, and Al2CO3. Now, all of those are just letters and numbers and things like that. So what I would do is I would take the opportunity to maybe pause the video, write down the example problems that we'll be going through, and following along with the chart. If you would like to, you can take a screenshot of this flowchart, or you can pause the video and just copy it down on your piece of paper so that you can have it for future problems. But you will eventually need to just kind of know how to do this. But this flowchart will allow you to get in the habit of what you need to do. So let's start with number 1, okay? We're going to use this kind of like orange, faded orange color to represent what we need to do, okay? So the first question does it have 2 elements only, okay? Now we know whether or not it has 2 or more elements based on how many capital letters we have. So we have 1 capital letter C and 1 capital letter C. So the answer is yes, it does have only 2. So we're going to follow that over here. But the next question is, does it have a metal in it? So we need to decide, is calcium a metal? Now we know calcium is on the left side of the staircase, so the answer is yes, it does have a metal. So we're going to follow kind of this arrow. So that means it is ionic, okay? Awesome, it's ionic. Now that means that it is not covalent. So when we look at an ionic compound, okay, we need to write it in the cation and then the anion form. So let's look at our cation first. We'll eventually go down both of these arrows here, but cation. We need to decide, is it a polyatomic? And the answer is no, okay? If it was a polyatomic, we would have noticed it up here, but it only has 2 elements. So we have to go no. If you go this way, you can really only, if you know that it only had 2 elements, then you couldn't possibly have a polyatomic. So when we come here, our next question is it a transition metal? Now, calcium is not a transition metal. It's in block uh, group 2. Okay, now we know that our transition metals are groups 3 through 12, okay? So it's not one of those. So it's not a transition metal, which means we just name it. So Ca is calcium. So we just write the name calcium. Okay, but now we need to come back to our anion. So we come to the next part. So the anion is it a polyatomic? Okay, and unless you came through this pathway, the answer is going to be no. Okay, we do not have a polyatomic. Okay, so now we would change the element ending to IDE. Now we know that Cl on the periodic table is chlorine, but we're going to change the ending from, instead of chlorine, to be chloride. Okay, so we changed that ending here. So our name for CaCl2 would be calcium chloride. Now let's look at our next example. We're going to use a red color to represent CCl4. So now the question is, does it have 2 elements only? Now I see a capital C here and a capital C here. This one's a little tricky, but this is indeed a lowercase l. So the answer is yes. I only have 2 elements. Now, does it have a metal? Well, carbon, my C, is a nonmetal, and chlorine is also a nonmetal, so the answer is no. Okay, now if I have only nonmetals, that makes it covalent, and I'm going to be using my prefixes. Okay, so it breaks it down. Element number 1, you put the prefix in front of the element except for mono. Okay, now as a refresher, our prefixes, 1 is mono. If you have 2, it's di. 3 tri, 4 tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. Okay, so those are your prefixes that you would add to the beginning of the element. So we know that C is carbon, and I only have one carbon here in this atom. If you have trouble counting how many atoms there are in there, I would maybe reference back to the counting atoms video. I only have one carbon. Okay, now the prefix for one is mono, but in our little chart here it says put the prefix in front of element name except mono, so we wouldn't write that. So we would just write carbon. Okay, so we've done this sides, but now we need to do the element 2 section. Okay, now element 2 can use all the prefixes, but you have to change the ending to IDE. So Cl is chlorine. Okay, but we have 4 of them. Now the prefix for 4 is tetra, so I would add tetra to the beginning, and I would need to change the ending to IDE. So instead of tetrachlorine, I'm in fact going to have tetrachloride. Okay, and that's how I would write my final answer. Okay, so now let's do our next one. We'll do number 3 in this green kind of color. Okay. All right. So again, does it have 2 elements only? I have a capital F and a capital O. So the answer is yes. Okay. And my colors and arrows are getting a little jumbled, but make sure you're following the green arrow. Okay. So the next question is, does it have a metal? Well, Fe is to the left of the periodic table. It's iron. So it does have a metal. So we're going to follow this arrow down, which makes it ionic. Now, if I'm ionic, we're going to have our cation and our anion. Okay, so we're going to have our positive side and our negative side. So if we look at our positive side, our cation, we need to know, is it a polyatomic? And the answer is no. We only have 2 elements, so we cannot have a polyatomic. Okay. Now, is it a transition metal? Iron is in groups 3 through 12. It's right in there. Okay. And so that means it is a transition metal, which means because it is a transition metal, we're going to need to use Roman numerals to indicate the charge. So we would write iron. We're going to put some parentheses here for the Roman numerals, and I'll show you how to figure out what number goes in there in just a moment. But we're going to switch over to our anion now. Okay. Now our anion, okay, is it a polyatomic? The answer is no. Remember, if you had a polyatomic, we would have determined it up here. Okay. But we do need to change the element ending to IDE. So oxygen becomes oxide. Now, to determine the Roman numeral there, we create a little chart. Okay. Now, on one side we write the positives, and on the other side we write the negatives. So we know that we have 2 iron atoms, okay, and we have 3 oxygen atoms. Now, based on our previous unit, we know that oxygen is going to have a -2 charge. And when I add up the total of my negative side, -2 plus -2 plus -2 is going to give me a total of -6. And this opposite side literally has to have the total opposite charge. And the opposite of -6 is going to be +6. Okay? And we're going to divide this 6 between the 2 iron atoms we have. And so when we have 6 divided by 2, we have a +3 charge. And that +3 is going to be the Roman numeral here. So it would be iron 3 oxide. Okay. So that is how you would get our Roman numeral. Now let's go to the next one. Okay, the next one we're going to do in this pink color here. Now, with this pink color, okay, our first question again is, does it have 2 elements only? And the answer is yes, indeed it does. It only has two elements. Okay, so we ask ourselves, does it have a metal? Well, nitrogen is a nonmetal, oxygen is a nonmetal, so the answer is no, which makes it covalent. So we look at our element 1, and then we go to element 2. So element 1, put the prefix in front. The prefix for 2 is di, and then we just write the word nitrogen because the symbol for capital letter N is nitrogen. For element number 2, again, we use our prefix tri for 3, but again, oxygen must change its ending to IDE, so be trioxide. All right, so let's go to our next one, which is going to be this slightly darker green. It might be a little hard to tell the arrows there, but the question is, does it have two elements only? Well, I have a capital M, a capital S, and a capital O. So it's actually no. It has three or more here. Okay, it does have three, in fact. And so that means it includes a polyatomic. So we're going to have to look for it on the back. And we can, the fact that there are 4 oxygens here tells me that this SO4 is probably going to be our polyatomic ion. So when we get to it, you're going to want to find that on our answer sheet on the back there. So we do have indeed a polyatomic. Now, that means it's going to be ionic, okay, regardless of whether or not we had a metal. But Mg is, in fact, magnesium and is a metal, so we could have also determined that it was ionic that way. Now, our cation. Okay, we have to decide if our cation is polyatomic. So we know our cation is always first. So we want to look to find if we can find Mgs on the polyatomic ion sheet. So if you take your periodic table and you flip it over, you want to figure out if you can find Mgs. If it's not there, then it's not a polyatomic ion. And in fact, it is not. Okay, so Mg is going to be our cation here. So the answer is no. And we ask ourselves, is it a transition metal? Well, magnesium is not a transition metal, so we would just name it as magnesium. Okay, so we've taken care of Mg. But now we go to our anion, okay, down this path. And the question is it a polyatomic? Well, what I have left is I have SO4 left. And if I look on the back of my periodic table, I will discover SO4 there. And so the answer is yes. And so we would just name it from the chart. So if you search for SO4, you'll see something that says SO4 -2, and it says the word sulfate out beside it. Okay, this is referring to the same thing. So we would just name it from the chart, and it would be magnesium sulfate. Okay, let's do the final one here. We'll do it in this kind of teal-ish blue color. Okay, we ask ourselves, does it have only 2 elements? Well, we have a capital A and a capital C and a capital O. So no, it has in fact 3 or more. And so that means it is going to include a polyatomic ion, and it will make it ionic. Okay, now with our ionic compound, we're going to start with our cation. Okay, now the great thing about this problem is these parentheses. Now these parentheses automatically tell me what my polyatomic ion is, and it's everything that's inside there. So CO3 is actually going to be the polyatomic. So my cation, which is listed first, is just going to be aluminum. So in fact, no, it is not a polyatomic ion. So we ask ourselves, is it a transition metal? Well, aluminum is not a transition metal, so we're just going to name it. So it would be aluminum. And CO3, our anion, is a polyatomic. Okay, and so that means we just name it from the chart. So it would be aluminum carbonate. And that is how we would name our elements. So you can use this flowchart to continue to help you practice the problems that were given to you in class.